What if I told you that deep in space, there's a planet where molten glass rains down at 7,000 kilometers an hour? Or how about a world that's somehow on fire, despite being entirely covered in ice? Sounds crazy, right? But this is scientific reality. Today, we're embarking on a journey to the 20 strangest, most unimaginable planets astronomers have ever discovered. These aren't just boring rocky spheres. These are worlds that completely shatter our understanding of what a planet can be. Get ready, because some of these places defy the very laws of physics and will completely change how you view the universe. By the way, what's the craziest idea of a planet you've ever had? Drop it in the comments below and we'll see if the universe matched your fantasy by the end of the video. Before we kick off this cosmic tour, let's quickly cover how we even know these worlds exist. Most of the planets on our list are exoplanets, that is, planets orbiting stars other than our Sun. Just a few decades ago, their existence was purely theoretical. But today, thanks to powerful telescopes like Kepler and the James Webb Space Telescope, we've discovered thousands of these worlds. Astronomers use ingenious methods to spot them. For example, there's the transit method, where they detect a tiny dip in a star's brightness as a planet passes in front of it. Or the radial velocity method, where they measure the star's barely perceptible wobble caused by the gravitational pull of its planets. This data allows scientists not only to confirm the planet's existence, but also to determine its size, mass, and even the composition of its atmosphere. And it's precisely the analysis of these atmospheres and parameters that has opened the door to a universe filled with cosmic monsters and truly bizarre wonders, which is exactly what we're going to dive into today. Let's start our journey with a place that is truly the stuff of nightmares for any space tourist. That planet is HD 18973b. At first glance, it looks like a beautiful, deep blue marble, reminiscent of Earth viewed from space. But don't let that colour fool you. That striking blue hue isn't caused by oceans. It's due to an atmosphere saturated with silicate particles, essentially molten sand. Temperatures on this planet soar past 1,000 degrees Celsius, which converts those silicates into liquid glass. But that's still not the worst part. The planet is scourged by winds clocking in at over 8,000 kilometers per hour, roughly 7 times the speed of sound. These supersonic gales pick up the drops of molten glass and whip them horizontally around the entire planet. Imagine an unending hypervelocity hailstorm, where the hail is sharp, molten glass shards flying at unthinkable speeds. That is the terrifying reality of the weather on HD 189733b. This planet, a hot Jupiter gas giant, is located a mere 63 light-years away in the constellation of Vulpecula. Its discovery and subsequent study using the Hubble Space Telescope marked a major breakthrough in analysing exoplanetary atmospheres. Scientists determined the planet's colour by observing how the system's light changed when the planet passed behind its star. The blue light that persisted revealed that the colour originated from the planet itself, not from reflected starlight. This finding proved that we can study the weather on worlds trillions of miles away, and that this weather can be truly monstrous and deadly. Any probe we sent there would be instantly ripped apart and melted. It is a world where deadly danger and superficial beauty collide, creating one of the most inhospitable corners in our known galaxy. So the next time you complain about a little rain, just remember those supersonic storms of glass. Let's now shift our focus to the complete opposite, a world of absolute darkness. Meet TRES-2b. This planet holds the undisputed title of the darkest exoplanet ever discovered. It orbits its star in the constellation Draco, roughly 750 light-years from Earth. What makes it so strange? It absorbs more than 99% of the light hitting it from its host star. This effectively makes it blacker than coal, blacker than fresh asphalt, blacker than any pigment you can possibly imagine. For comparison, even our own moon, which looks quite dark, reflects about 12% of the sun's light, while Earth reflects about 30%. TRES-2b truly is a black hole among planets. Scientists were astonished when the Kepler Space Telescope measured its albedo, or reflectivity. They had expected a Jupiter-like gas giant to bounce back a significant amount of light thanks to its dense, reflective clouds. But the reality proved far stranger. The atmosphere of TRES-2b contains virtually no reflective clouds. Instead, it's packed with light-absorbing chemicals, such as vaporized sodium, potassium, and gaseous titanium oxide. These elements essentially eat the photons, preventing them from ever reflecting back into space. Despite its extreme darkness, the planet is not cold. In fact, it belongs to the hot Jupiter class and is superheated to temperatures approaching 1,000 degrees Celsius. Because of this infernal heat, it isn't completely black. It actually emits a faint, dim, deep red glow, like a barely visible ember or the coil of an electric stove. It's incredibly difficult to visualize such a world. A gigantic, superheated ball hanging in the void, yet practically invisible, merely smouldering softly in the darkness. The discovery of TRES-2b forced astronomers to fundamentally rethink their models of planetary atmospheres and demonstrated just how diverse they truly are. This world is living proof that even in something as seemingly simple as the reflection of light, the universe is capable of delivering the most incredible surprises. If the last planet we discussed was blacker than coal, the next one on our list sparkles brighter than any jewel. Get ready to meet 55 Cancri, often called the Diamond Planet. This world, located 40 light-years away in the constellation Cancer, is a true gem, both for astronomers and for anyone who loves things that sparkle. It is classified as a super-Earth, a planet that is larger and more massive than our own, but still smaller than gas giants like Neptune. Its defining feature, however, lies in its hypothesized composition. Initial models based on its mass and radius strongly suggested the planet must be incredibly rich in carbon. The system's host star also exhibits a high carbon-to-oxygen ratio. This led scientists to an astonishing hypothesis. If the protoplanetary disk was abundant in carbon, then the planet itself likely formed predominantly from it. Given the enormous pressure and temperature deep inside 55 Cancri, that carbon should have crystallized, effectively converting into diamond. According to some estimates, up to 1/3 of the planet's total mass could be composed of pure diamond. Imagine a world whose core is a gigantic, shimmering crystal, covered by layers of graphite and other carbon compounds. The planet's surface is likely a boiling ocean of tar and molten methane, with temperatures on the day side soaring up to 2,400 degrees Celsius. That's hot enough to melt most metals. The planet orbits so close to its star that a year there lasts a mere 18 hours. It is also likely tidally locked, meaning it always presents the same face to its star, much like our moon does to Earth. This results in a colossal temperature difference between the perpetually sunlit side and the eternally dark side. Now, the diamond planet hypothesis is still a subject of scientific debate. More recent research suggests that the composition may not be quite so exotic. Nevertheless, the sheer possibility of a world where diamond is bedrock, not a rare mineral, captures the imagination. It demonstrates that planets can form from widely different building blocks, and our own silicate-rich Earth composition is just one of the countless options the universe has to offer. Prepare yourself for a genuine scientific paradox, a planet that is simultaneously scorching hot and yet composed primarily of ice. It sounds utterly fantastical, but this is the actual description of Gliese 436b. This Neptune-sized world orbits a red dwarf star in the constellation Leo, just 33 light-years away, and it has completely stumped researchers. Surface temperatures on this planet soar past 439 degrees Celsius. At that extreme heat, water on Earth would instantly vaporize. Yet, on Gliese 436b, that water exists as an exotic solid form of ice, often referred to as Ice 7 or Ice 10. How is this possible? The answer lies in the planet's incredible gravitational force. Although it is only the size of Neptune, Gliese 436b possesses an extremely dense core. This results in gravity so immense that it brutally compresses water molecules. This crushing pressure prevents the water from vaporizing, even under these extreme temperatures. Instead, the molecules compact into a solid state, forming what scientists call hot ice. This substance bears no resemblance to the cold, brittle ice we know. It is dense and rock-hard, yet it is simultaneously searingly hot. Gliese 436b's surface is likely shrouded in this peculiar material. But the oddities don't stop there. The planet is surrounded by a massive atmosphere, composed mainly of hydrogen and helium. Under the intense radiation of its star, this atmosphere is literally boiling off into space. It leaves behind an enormous, comet-like tail of escaping hydrogen, stretching for millions of kilometers. Researchers have also noted a baffling scarcity of methane in the atmosphere, despite models predicting high concentrations. This strongly suggests unknown and highly exotic chemical processes are at work on this strange world. Gliese 436b is the ultimate illustration of how our common terrestrial assumptions about matter, that ice is cold and steam is hot, completely break down in the extreme environments of other worlds. This planet serves as a powerful reminder that the fundamental laws of physics can produce results that are profoundly illogical and paradoxical to our human perception. Let's now delve into the deep past of the universe, meet the elder statesman of planets, a true cosmic patriarch, PSR B162026b, unofficially known as Methuselah. This planet is one of the oldest ever discovered. Its age is estimated to be a staggering 12.7 billion years. Just to put that number into perspective, our Earth is only 4.5 billion years old, and the solar system is just slightly older. Methuselah formed when the universe itself was still in its infancy, barely 1 billion years old. This means the planet has witnessed the birth and death of countless stars and galaxies, but its age is only one of its peculiarities. The second, and equally astonishing fact, is its location and its family. Methuselah doesn't orbit just one star, but two, and what an unusual pairing they are. One star is a pulsar, a super-dense, rapidly spinning neutron star left behind after a supernova explosion. It blasts out powerful beams of radiation like a cosmic lighthouse. The second star is a white dwarf, the cooling core of a star that was once similar to our own sun. This exotic triple system resides within the globular cluster M4, located in the constellation Scorpius. Globular clusters are ancient, tightly packed groups containing hundreds of thousands of stars. Previously, it was believed that planets simply couldn't form in such environments due to low metallicity, a lack of heavy elements, and constant gravitational disruption from neighbouring stars. However, the discovery of Methuselah completely overturned these assumptions. It proved that planets could form during the very earliest stages of the universe's existence, even when the heavy elements that make up us and our planet were extremely scarce. This gas giant, roughly 2.5 times the mass of Jupiter, is a living witness to those distant times. Its survival in such a chaotic and ancient environment raises profound questions for astronomers about how and where planetary systems can originate. Methuselah is more than just a planet. It is a time capsule carrying vital information about the dawn of cosmic history. Imagine Earth but transformed into an infernal fireball. That essentially is Kepler 78b. This planet is one of the most astonishing super-Earths, primarily because it's almost an exact replica of our own planet in terms of size and density. Yet it exists in completely unimaginable conditions. Its diameter is only 1.2 times that of Earth, and its mass is 1.7 times Earth's. This means that, just like our home planet, it is composed mainly of rock and iron. But that's where the similarities end. Kepler 78b orbits so incredibly close to its parent star that it completes a full revolution in just 8.5 hours. Yes, its entire year is shorter than one working day on Earth. This extreme proximity turns the planet into a true hellscape. Surface temperatures are estimated to be between 2000 and 2500 degrees Celsius. That's hot enough to melt not just rock, but also iron. The entire surface is likely a churning ocean of molten lava. Any mountains or continents that might have existed there have long since liquefied into flowing rock. Any atmosphere it might have once had was likely stripped away long ago by the powerful stellar wind. This planet is, quite literally, a naked, molten ball of rock. The biggest mystery surrounding Kepler 78b, however, is how it got there in the first place. According to current theories of planet formation, it should not have been able to form so close to its star. In that specific zone, the temperature of the protoplanetary disk was far too high for solid particles to condense. This strongly suggests that the planet formed much further out in the system and then migrated inward toward its star, but the mechanism that caused it to stop at such an incredibly tight orbit, literally a hair's breadth from being consumed by the star, remains a major question mark. Kepler 78b serves as an extreme laboratory for scientists studying planetary evolution. It demonstrates the potential fate of rocky planets in intensely hot systems. And perhaps more importantly, it serves as a stark reminder that a planet similar to Earth in composition can be absolutely and utterly different in conditions, having transformed into a veritable forge world. Some planets are just weird, but others are condemned to a slow and agonizing death. WASP-12b falls squarely into the latter category. This hot Jupiter is famous for several reasons, all of them rather grim. First, it is one of the hottest known planets, with daytime temperatures soaring to about 2,200 degrees Celsius. Second, it is one of the darkest worlds, rivaling TARES 2b, reflecting almost no light, but its most defining feature is its fate and its bizarre shape. WASP-12b orbits so close to its star that it is literally being torn apart. The star's immense tidal forces are stretching the planet, morphing it from a sphere into the shape of a colossal egg. One end of this egg is perpetually elongated toward the star, but the drama doesn't end there. The star's gravity is so powerful that it is actively stealing the planet's atmospheric material. Gas is being stripped away from WASP-12b, forming a massive accretion disk around the star, slowly spiraling inward. Essentially, we are witnessing in real time a star devouring its own planet. This process is happening at an incredible rate. The planet is losing about 6 billion tons of material every single second. Astronomers estimate that at this rate of stellar consumption, WASP-12b will be completely destroyed in just 10 million years. On a cosmic timescale, that is merely an instant. Furthermore, an unexpectedly high concentration of carbon has been detected in this doomed planet's atmosphere. This makes it the first known carbon planet, which again raises the tantalizing idea of diamond cores, or even mountains made of graphite and carbides. WASP-12b is a dramatic and brutal spectacle. It offers us a glimpse into the final evolutionary stages of planets positioned too close to their parent stars. It is a stark demonstration of the irreversible power of stellar gravity and a reminder that even giant worlds, hundreds of times more massive than Earth, are defenseless against their parent stars. We have witnessed cosmic cannibalism in action. If some planets have rains of molten glass, why shouldn't others have showers of precious gems? Welcome to HAT P7b, a world where the clouds are likely made of rubies and sapphires. This planet is another classic hot Jupiter, located over 1,000 light-years away from us in the constellation Cygnus. Its extremely tight orbit keeps it blisteringly hot, but the most fascinating aspect of HAT P7b is its weather. Observations using the Kepler Space Telescope revealed that the brightest spot on the planet is constantly shifting. This movement suggests the presence of powerful dynamic winds and a chaotic cloud system. Scientists hypothesized that clouds form on the cooler, night side of the planet. Intense winds then rapidly push these clouds to the day side, where they quickly evaporate in the scorching heat. This constant cycle is what causes the observed changes in brightness. So, what exactly forms these clouds? Given the extreme temperatures, water vapour is absolutely out of the question. The most likely candidate is corundum, a mineral whose crystalline forms are rubies and sapphires. On the planet's night side, where it's relatively cooler, gaseous corundum condenses into tiny liquid droplets, forming clouds of molten gemstones. These clouds are then swept away to the day side, where the intense heat vaporizes them again. It's possible that these clouds even produce rainfall made of liquid rubies and sapphires. Imagine a sky filled with glittering crimson and sapphire clouds, literally dripping jewels. While this sounds like a jeweler's dream, for any living organism, it would be pure hell. Beyond its exotic weather, HAT P7b holds another surprising detail: its orbit. It actually revolves around its star in the opposite direction of the star's rotation. This is known as a retrograde orbit. Such motion is highly unusual and strongly suggests a violent past for this system. It's likely that long ago, a gravitational interaction with another planet or nearby star literally flipped HAT P7b's orbit inside out. This world serves as a perfect example of how detailed observations of a distant planet's brightness can reveal secrets about its incredible weather and dramatic history. We all know Saturn and its magnificent rings. Now imagine a planet whose rings are 200 times larger and more massive. Meet J-7b, unofficially nicknamed Super Saturn. This object is so bizarre that scientists are still debating whether it's a true planet or a brown dwarf, a so-called failed star. But what is beyond doubt is its absolutely gigantic ring system. This system spans about 120 million kilometers in diameter. To put that into perspective, that's nearly the distance from the Earth to the Sun. If our own Saturn had rings like these, they would completely dominate the night sky, appearing many times larger and brighter than a full moon. J-7b's ring system consists of over 30 separate rings, and it's so dense that it blocks a significant amount of light from its host star when it passes in front. It was actually this immense eclipse, which lasted a staggering 56 days, that allowed astronomers to detect this incredible structure in the first place. Within the rings, there are distinct gaps and clear divisions. Scientists theorized that these were carved out by exomoons, satellites orbiting this gargantuan planet. One particular gap suggests the possible presence of a moon the size of Mars, or perhaps even Earth. The planet J-1407b itself is estimated to have a mass between 10 and 40 times that of Jupiter, which is exactly why it sits right on the borderline between a true planet and a brown dwarf. It orbits a young, sun-like star at a vast distance, and its year lasts about 10 Earth years. The origin of such a massive ring system remains a major mystery. Perhaps they are the remnants of a protoplanetary disk, currently forming new satellites. Or maybe they are the debris from a large moon that was torn apart by the planet's immense gravity. Either way, J-1407b gives us a unique opportunity to peek into the past of our own solar system and see how moons might have formed around our gas giants. This Lord of the Rings, on a galactic scale, truly pushes the boundaries of our understanding of what planetary systems can be. If you thought hell was hot, you clearly haven't heard about Kelt 9b. This planet officially holds the title of the hottest exoplanet ever discovered. It is so blisteringly hot that it surpasses the temperatures of many stars. Temperatures on its day side reach a staggering 4,300 degrees Celsius. To put that in perspective, the surface of our Sun is only about 5,500 degrees. In fact, many red dwarf stars, the most common stars in the universe, are far cooler than this planet. Kelt 9b is a gas giant, nearly 3 times the mass of Jupiter. It orbits an incredibly hot, bright blue star that is twice the size and temperature of our own Sun. The planet follows a perilously close orbit, completing one revolution in just a day and a half of Earth time. It is also tidally locked, meaning one side is eternally facing this blue stellar inferno. The extreme ultraviolet radiation from the star is literally blowing away the planet's atmosphere. It is shedding mass at an enormous rate, leaving behind a giant, comet-like tail of evaporated gas. Due to the monstrous heat on the day side, molecules cannot even exist. Compounds like water, carbon dioxide, or methane are instantly ripped apart, dissociating into individual atoms. Vaporized heavy metals, such as iron and titanium, have been detected in Kelt 9b's atmosphere, existing purely in a gaseous state. This is a world where it rains molten iron. On the slightly cooler night side, these metals can condense into droplets and fall as precipitation, only to be swiftly swept back to the day side and instantly revaporized. Kelt 9b is a unique object that truly blurs the line between a planet and a star. It is subjected to such intense radiation that its very existence is a constant battle for survival. Scientists believe that eventually the star will completely boil away the entire gaseous envelope, leaving behind only a bare, super dense core. If that is, the core manages to survive this cosmic apocalypse. The universe is filled not only with terrifying, but also uniquely beautiful worlds. One such example is GJ 504b, unofficially known as the Pink Planet. It's a gas giant orbiting a sun-like star in the constellation Virgo. What makes it stand out is its striking colour. Observations reveal the planet glows with a deep magenta or purplish hue. According to scientists, this colour is a sign of its youth. GJ 504b is incredibly young, clocking in at only about 160 million years old. For comparison, Earth is 4.5 billion years old. Because of this youth, it's still extremely hot, around 237 degrees Celsius. This heat is the residual energy left over from its formation process. It is this internal heat that causes it to glow brightly in the infrared spectrum, and as this light passes through its atmosphere, it gives the planet its unusual pink tint. It is one of the few exoplanets that astronomers have managed to photograph directly. Usually, we detect planets using indirect methods, but GJ 504b orbits far enough from its star that its faint glow can be captured by specialized telescopes equipped with adaptive optics. But its colour isn't the only mystery. The planet is located at an enormous distance from its star, roughly 44 times farther than Earth is from the Sun. That's significantly farther than Neptune is in our own system. This distant positioning doesn't align with the standard model of planet formation, known as the core accretion model. This theory suggests that gas giants form closer to the star, where material is abundant and then might migrate outward. GJ 504b is simply too far away to have formed in this manner within the expected timescale. This forces scientists to consider alternative hypotheses, such as the gravitational instability model, where the planet forms directly from the collapse of a dense clump within the protoplanetary disk. The Pink Planet is not just a beautiful sight, it's a crucial key to unlocking the mysteries of planet formation, demonstrating that giant worlds can be born in the most unexpected places. Star Wars fans have always dreamed of seeing a planet with two suns, just like Tatooine. Well, astronomers found one. In fact, they found several, but the most famous of these discoveries is Kepler 16b. This was the first truly confirmed planet found orbiting not just one star, but an entire binary star system. Planets like this are known as circumbinary planets. Kepler 16b is located about 245 light-years away in the constellation Cygnus. It's a coal gas giant, roughly the size of Saturn, and scientists estimate its composition is half gas and half rock and ice. Its parent stars are two red dwarfs, both smaller and cooler than our own Sun. They orbit each other in a tight 41-day cycle, while the planet itself circles this spectacular dancing duo of stars every 229 days. Just imagine the sunset on such a world. You might watch one sun dip below the horizon, followed shortly after by the second, or they could set simultaneously, casting double shadows across the surface. The sky on Kepler 16b would be an absolutely fantastic sight. However, unlike the desert world of Tatooine, life on Kepler 16b is highly unlikely. It resides far outside the so-called habitable zone of its binary pair, with surface temperatures plummeting to -70 to -100 degrees Celsius. The discovery of Kepler 16b was a crucial confirmation that planets can indeed form and maintain stable existence even in the complex gravitational environment of a binary star system. Previously, many astronomers doubted this, believing that the gravitational perturbations from two stars would simply eject any forming planet or cause it to crash into one of them. But this world proved that nature found a way to create stable orbits, even amidst such chaos. Kepler 16b opened up an entirely new class of planets for study and showed us that the boldest fantasies of science fiction writers might just be reality. What if you took an Earth-sized planet and forged it almost entirely out of iron? The answer is Kepler 10b. It was the first confirmed rocky exoplanet discovered by the Kepler telescope, and it turned out to be incredibly strange. This world is only about 1.4 times the size of Earth, yet its density is much, much higher. It clocks in at around 8.8 grams per cubic centimetre, comparable to the density of pure iron itself. This makes Kepler 10b one of the densest planets ever found. It likely harbours a colossal metallic core, accounting for a significant fraction of its total mass. Like many other extreme worlds, it orbits perilously close to its host star, 20 times closer than Mercury orbits our own Sun. A single year there lasts just 20 hours. Due to this extreme proximity, temperatures on its dayside soar above 1,300 degrees Celsius. That's hot enough to melt iron. Consequently, the planet's surface is likely covered by an ocean of boiling magma, where evaporating silicates and metals form a thin, tenuous atmosphere. Scientists theorize that Kepler 10b might be a so-called Chthonian planet. This is a hypothetical class of worlds that started out as gas giants, similar to Jupiter or Neptune, but after migrating too close to their host star, powerful radiation and stellar winds completely stripped away their gaseous envelopes. All that remains is their ultra-dense, exposed core, which continues its orbit. If this hypothesis holds true, Kepler 10b is literally the bare, exposed heart of a dead giant world. Studying objects like this allows astronomers to peek into the deep interiors of gas giants, revealing structural secrets that are impossible to observe directly. Kepler 10b is a harsh and deeply inhospitable world. It proves that even planets similar to Earth in size can have vastly different origins and compositions, transforming into giant metallic spheres, baked white hot under the glare of their star. We've heard tell of rains made of glass or even precious gemstones. But how about a literal downpour of rocks? That's exactly the kind of weather likely reigning supreme on the exoplanet Kourou-T 7b. Discovered by the European Kourou-T Space Telescope, this world quickly became a major milestone in exoplanet research. It was the first super-Earth for which scientists could accurately measure both its mass and radius. This precision allowed them to confirm its density and solidify its identity as a rocky world. Kourou-T 7b orbits a star in the Monoceros constellation, about 490 light-years away. And, as you might have guessed, it resides in an extremely close orbit. A single year here lasts a mere 20 hours. The planet is tidally locked. As a result, one side permanently faces its star, while the other is plunged into eternal darkness. On the scorching day side, temperatures reach 2,200 degrees Celsius. This heat is intense enough to vaporize solid rock. Yes, stones literally boil on this planet. The surface of the day side is a gigantic ocean of lava. This lava ocean constantly evaporates, creating a thin atmosphere composed of vaporized silicon, iron, magnesium, and other minerals. Essentially, it's an atmosphere of rock vapor. Powerful winds carry this vapor across to the night side, where conditions are drastically cooler. There, the rock vapor condenses, forming clouds made of tiny droplets of molten rock. It's from these clouds that precipitation falls, a rain of pebbles and sand solidifying mid-flight. These rocky snowflakes and raindrops plummet toward the surface, which is likely covered by a crust of solidified lava. Thus, Kourou-T 7b hosts a unique geological cycle: evaporation on the day side, transfer and condensation in the atmosphere, and finally, precipitation as rock rain on the night side. This world is a living demonstration that geological processes aren't confined solely to a planet's interior, but can play out dramatically within its atmosphere as well. Kouro T7b is a truly hellish world, where the very ground melts, vaporizes and rains back down from the sky, creating one of the most bizarre weather cycles in the entire universe. Let's take a quick break from the searing heat and journey to an icy wasteland. The planet Ogle 2005 BLG 390 LLB is one of the coldest and most distant worlds ever discovered. Unofficially, it's sometimes nicknamed Hoth, after the infamous ice world from Star Wars. It was discovered using gravitational microlensing. This technique is crucial for finding small, distant planets that other methods simply can't detect. Essentially, when a star and its planet pass precisely in front of a more distant background star, the foreground star's gravity acts as a lens, briefly amplifying the background light. Crucially, the planet's presence causes a specific, temporary distortion in that magnification, which is what reveals the planet itself. Ogle 2005 BLG 390 LB is a small rocky world, estimated to be about 5 times the mass of Earth. It orbits a cold red dwarf star, located more than 21,000 light-years away, nestled close to the centre of the Milky Way galaxy. Its host star is exceptionally dim, and the planet maintains a wide orbit, roughly equivalent to the distance between the Sun and our own asteroid belt. This combination of a faint star and a large orbital distance results in truly bitter, eternal cold. The surface temperature is estimated to be minus 290 degrees Celsius, or negative 364 degrees Fahrenheit. That is only 50 degrees above absolute zero. At these temperatures, any gases that might have formed an atmosphere, like nitrogen, oxygen, or carbon dioxide, would have long since frozen solid and precipitated onto the surface as a kind of snow. The entire planet is likely a barren sphere of rock, encased in a thick shell of frozen gases and water ice. It is truly a world of perpetual deep freeze and absolute silence. Its discovery was significant because it proved that small, rocky, Earth-like planets can form even around the tiniest and coldest stars, suggesting that such worlds might be incredibly common throughout our galaxy. Ogle 2005 BLG 390 is Alibi serves as a stark reminder that the universe consists not only of blazing fireballs, but also of countless frigid, icy worlds, forever lost in the cold darkness of deep space. Most of the planets we discuss are part of well-established star systems, but what if a planet is completely alone? Meet HD 1069006b, arguably the loneliest planet known to science. This gas giant, roughly 11 times the mass of Jupiter, orbits its binary stars at an almost unimaginable distance, more than 650 astronomical units. An astronomical unit, or AU, is the average distance between the Earth and the Sun. To put that in perspective, this planet is 650 times farther from its stars than we are from ours. That's over 20 times farther out than Neptune is from the Sun. At this staggering distance, the gravitational tether to its stars is incredibly weak. A single orbit around them takes the planet approximately 15,000 years. If you could stand on the surface of this world, its stars would appear merely as 2 very bright dots in the sky, barely distinguishable from other distant stars. This world is perpetually shrouded in frigid cold and twilight, but the planet's enormous distance is the core mystery. Current theories of planet formation simply cannot explain how such a massive gas giant could form so far out. That region of the protoplanetary disk wouldn't have had enough material to create a giant of this scale in any reasonable time frame. This has led scientists to 2 main hypotheses. The first is that HD 1069006b is not actually a planet, but a failed star, specifically a brown dwarf, that formed alongside its 2 companions from the same gas cloud, essentially starting life as a triple star system. The second, and more intriguing, hypothesis is that this planet is an exile. It might have formed much closer to its stars in a more normal region. But then, a powerful gravitational interaction with another, perhaps yet to be discovered planet within the system, ejected it into this distant, highly elongated orbit. It was literally cast out to the very edge of its own system. Studying such solitary worlds helps us understand the immense dynamics and chaos that can govern young planetary systems. HD 1069006b stands as a monument to cosmic instability, a giant orphan abandoned at the furthest edge of its stellar home. When we talk about strange new worlds, we have to mention our closest neighbour outside the solar system, Proxima Centauri b. This planet orbits Proxima Centauri, the nearest star to us, which happens to be a red dwarf. It's located only 4.2 light-years away. That makes it the closest exoplanet we know of. But its proximity isn't the only thing that makes it fascinating. Proxima b is a rocky world, only about 1.17 times the mass of Earth. Crucially, it sits right within its star's so-called habitable zone. This is the region where surface temperatures allow water to exist in liquid form, a key requirement for life as we know it. It seems like we've found our second home. But the reality is far more complex. Proxima b is a world of extremes. Because it orbits a very dim red dwarf, its habitable zone must be incredibly close to the star. A year on the planet lasts just 11 Earth days. This close proximity almost certainly means the planet is tidally locked. One side perpetually faces the star, while the other is plunged into eternal darkness. This creates a colossal temperature differential. While the day side might be warm enough for liquid water, the night side is gripped by icy cold. The only potentially habitable region might be the terminator, the line between day and night, where eternal twilight reigns. But the major issue for life on Proxima b is its star. Red dwarfs, especially younger ones, are extremely active. They unleash powerful stellar flares that blast massive amounts of radiation and charged particles into space. Proxima Centauri regularly showers its planet with X-ray radiation hundreds of times more powerful than what our Sun emits during its strongest storms. This level of radiation would likely have stripped the planet's atmosphere long ago, sterilizing its surface and wiping out any potential life. Thus, Proxima b is a profound paradox. It sits in the perfect location, but orbits a terrible star. It tantalizes us with its proximity and Earth-like potential, yet simultaneously serves as a stark reminder of how dangerous and inhospitable the cosmos can be. Astronomers have long hunted for a second Earth, a planet matching ours in size, orbiting a star similar to the Sun and comfortably nestled within its habitable zone. In 2015, they finally found one of the best candidates yet, Kepler 452b. It's often dubbed Earth's cousin, or Earth 2.0. This intriguing world lies 1,400 light-years away, nestled in the constellation Cygnus. The planet is about 1.6 times the size of Earth and is most likely a rocky super-Earth. Crucially, it orbits a G2-type star, essentially a twin of our own Sun. Most importantly, its orbital period is 385 days, almost exactly matching an Earth year. This places it smack in the middle of its star's habitable zone, receiving roughly the same amount of solar energy that we enjoy here. All these factors make Kepler 452b an incredibly compelling target. If the planet possesses an atmosphere and liquid water, surface conditions could be perfectly comfortable for life. However, there are several significant caveats. First, its host star is significantly older than our Sun, by about 1.5 billion years, clocking in at roughly 6 billion years old. This means the star has grown brighter and hotter. Consequently, Kepler 452b may now be experiencing the final stages of its habitable lifespan. The intensifying stellar radiation could have already triggered a runaway greenhouse effect, boiling off any oceans and transforming the world into a Venus-like wasteland. Second, due to its increased mass, the surface gravity would be roughly twice that of Earth. This factor alone would create radically different conditions for the evolution of any hypothetical life forms. Despite these uncertainties, Kepler 452b remains one of the most vital discoveries in the ongoing search for extraterrestrial life. It proves that planets incredibly similar to our own truly exist throughout the universe. While we can't yet confirm whether life exists there, its mere presence gives us hope that somewhere deep in the cosmos there is another blue dot waiting to be found. Imagine a planet so incredibly light and fluffy that its density is comparable to cotton candy. This isn't science fiction. It's the reality of the exoplanet WASP 1007b. Located about 200 light-years away, this gas giant defies our fundamental understanding of how planets form and evolve. WASP 107b is roughly the size of Jupiter, yet its mass is only about 1/10 that of Jupiter. This makes it one of the least dense exoplanets ever discovered. To put its low density into perspective, if you could build a bathtub large enough, this planet would float on water like a cork. How did such an airy world even come into existence? Scientists are still scratching their heads over this enigma. Standard planetary formation models predict that to accumulate such a vast gaseous envelope, the planet's core must be far more massive. WASP 107b, however, appears to have an exceptionally small core. This suggests either our current theories are incomplete or some truly exotic processes were involved in its formation. One hypothesis is that the planet formed much farther from its star, in the colder regions of the protoplanetary disk, and then migrated inward. Another idea is that its atmosphere is intensely heated by internal warmth or tidal forces from its star, causing it to puff up to its incredible dimensions. The most astonishing breakthrough concerning WASP 107b, however, came from analysing its atmosphere. Using the Hubble Space Telescope, astronomers achieved a first. They detected helium in the atmosphere of an exoplanet. This element is notoriously difficult to spot, but the planet's bloated and diffuse atmosphere made the detection possible. Finding helium provides a crucial clue to understanding how planets lose their atmospheres over time. WASP 107b is a truly unique natural laboratory for studying planetary atmospheres. Its strange, fluffy nature makes it an ideal target for observation, helping scientists test and refine their models of planetary evolution, and ultimately proving that even cosmic giants can be astonishingly light. We've seen gas giants with no solid surface, and we've seen bare, rocky cores. But what if there's something in between? The exoplanet TOE 849b appears to be exactly that. This unique object is likely the exposed core of a gas giant. Unlike other candidates for this designation, however, it isn't scorching hot and maintains a relatively comfortable, though close, orbit. TOI 849b is roughly 3.5 times larger than Earth in diameter, yet it is 40 times more massive. This makes it incredibly dense. So dense, in fact, that it cannot be classified as a typical super-Earth. Its overall density is comparable to Earth's, despite its enormous size. The only feasible explanation is that the planet is almost entirely composed of heavy elements: iron, silicates, and potentially a small amount of water compressed into exotic states. Scientists believe we are looking at what was once the core of a giant planet comparable to Jupiter or Saturn, but for some reason it was stripped of its massive gaseous envelope. How could this have happened? There are several prevailing theories. The first is photoevaporation. The planet may have orbited even closer to its star in the past, allowing powerful stellar radiation to simply blow away the entire atmosphere. The second theory involves a massive collision. During the system's volatile early life, TOI 849b might have collided with another giant planet. This catastrophe would have ripped away the atmosphere, leaving only a scarred core behind. The third, and perhaps most intriguing theory, is failed formation. It's possible the planet simply didn't accrete enough gas from the protoplanetary disk before that material dissipated. It built a massive core, but the essential building blocks for a massive atmosphere vanished too soon. Whatever the true mechanism, TOI 849b offers a unique opportunity to study the internal structure of gas giants. We can directly observe what is typically hidden beneath thousands of miles of dense cloud cover. This strange world caught between a terrestrial planet and a gas giant holds the key to understanding the entire spectrum of planetary diversity in the universe. What a revelation! From planets where molten glass or precious gems rain down, to worlds being consumed by their own stars, or simply drifting alone in the interstellar void. Today, we've seen proof that the universe is far stranger, more inventive, and sometimes crueler than any science fiction story we could invent. Each of these 20 worlds is not just a dot on a star chart. They are a profound challenge to our imagination and to everything we thought we knew. Diamond planets, burning ice, the darkest and hottest corners of the galaxy, all of this clearly demonstrates how little we truly understand, and how many incredible wonders and horrors still await discovery. Every single discovery like this is a small, vital step toward understanding our place in this boundless cosmos. Thank you for joining us on this incredible journey. If your brain hasn't completely melted from these cosmic oddities yet, make sure you hit the like button on this video and subscribe to the channel so you don't miss our next discoveries. Click the notification bell and you'll be the first to hear about the most insane corners of the cosmos. Now for the big question, which of these 20 planets blew your mind the most? And if you had the chance to send a probe to just one of them, which would you choose and why? Let me know your answers in the comments below. Until next time, keep looking up.